Okay. So when we're talking about vector components, the components are typically going to be x and y. So that's the first thing we're going to write right at the top. When I talk about components, I'm talking about good old math friends, x and y, which we, on the paper at least, we're going to refer to as horizontal across and vertical up and down. So we're like to make triangles at right angles, and we like to have there be an x component, so the part of it that's up and down, and a y component, the part of it that's left and right. And so part of what? What am I talking about? Each vector itself has an x and a y component, and each resultant will have an x and a y component. So we're going to zoom way in on this diagram here, and we're going to just examine it. So the first thing I would say is they're added together tail to tip. So you're adding two vectors, but they're not at right angles like they were before. So a big problem would be if you tried to just draw a line and treat them like they were right angle, because they're not. But we can get the resultant. We can very carefully draw in from the beginning of our journey to the end, and this would be, don't make it too big, okay? Make a nice smallish size R there. We've got an R. So that is our resultant. So if I was using a graphical method, meaning if I was measuring this with my ruler and I was measuring the angle with a protractor, I could get this answer. On the test, you may be asked to measure angles like this using your protractor, and then, actually I'm going to say you will be asked. You will be asked to measure the angles like this with your protractor and then add them together, so move them from one place to another and draw them in. So our ability to draw careful scale diagrams and get our angles correct is really important. But we still want to probably do the math. In order to get the answer, we want to do the algebraic solution with Pythagoras and trig. So that's what I'm going to be solving right now. Assuming I'm not just measuring this with a ruler, how would I do it? What I want to do is I want to get the x and the y component of my answer. So this is a big square here, so I'm just going to add my tip here, showing the direction, even though it actually goes all the way to here, okay? The length of it is all the way to here. So the first thing I want to do is I want to, and it's nice to use a corner, like a square if you can. I want to actually go along the side here and up to the top there and find my triangle. I want to make my resultant triangle. So what I'm saying is, if this resultant here is at an angle like this, I can make a 90-degree triangle or right angle triangle, and I would then refer to this side as RX. The x component of the resultant. And I would refer to this one here as RY, the y component of this resultant. In the previous examples that we did, Rx and Ry were just the two vectors because they were at right angles, but they're not anymore. So I want to think about, and maybe draw my Rx and my Ry. I have an arrow here that's showing the direction of this one, because if you look at R is going northeast, right? So this one has to go east, and this one has to go north. I need to recognize the direction of my Y and my X as well, because that will help me determine the direction of my resultant if I didn't know it, or if I was asking for RY, or if I was asking for RX. So it's going to go, if you think about it like this, let's say you flew a little drone along this line R. If I was talking about the displacement, it would mean that you had traveled a little bit north and a little bit east. And we could figure out how far north you went and how far east you went. And that will lead to some other questions later on. We'll be talking about how far in the north direction did you travel, how far in the east direction did you travel? How am I going to get these answers? Well, I'm going to make more triangles. So in this vector here, I'm going to label it V1, vector 1. So I'm not referring to velocity right now. It's just a general example, so it could be whatever. And then this one here, I'm going to label it V2. I'm purposely labeling it on the inside right now, guys, because I have a plan. So try and follow along. You can watch the video later if you want to slow it down. I'm going to use my triangle again, or my square edge, to make this little tiny V1 also into a right triangle. So I'm just going to line it up. I'm not doing a scale diagram, so I'm not going to be really, really fussy. But this is the gist of it. So now if I've got a right angle triangle here, and this is my vector, I can give direction to this. So I know that this little bit here is an up or north or whatever the direction is there that's positive. And then this little guy is going this way. I want to make sure to include those arrows. You're not drawing triangles, you are drawing vectors. Then I'm going to label it for you guys. I think we'll draw both of them first, just so you can see where you can write and where you can't. So I'll add the next drawing. The next drawing is for this vector here, vector 2. Vector 2 also has two components that I can use to make it a right angle triangle. Thusly, oh, I want to move it up a little. Okay, there we go. So this right angle triangle here has, again, we'll say north, positive direction there. And in addition, it's also going this way, positively this way. East, we were saying. Okay, so we're going to label those components of the vector 1 and the vector 2. This is what I'm going to call y2. And this is what I'm going to call y1. This y dimension that is in the upward or north direction. So then over here we're going to have x1. And here, see how it's kind of tight? That's why I wanted to draw them both so you could see what I'm labeling. Hopefully, this is x2 and this is y1. They're close together, so hopefully that's clear. So ultimately, guys, you can visually see, you can observe this. They sum to give you x, rx, and ry. In this example, both of these vectors are in the same direction. That's not always true. So vector 1 is going northeast, and vector 2 is also going northeast. But I could have vector 2 going back the other way or downwards. You'll see lots of different examples. So in this example, they happen to be going the same way, which is really convenient because it makes it very easy. If I wanted to get Rx, think of this as a grade 5 math question. Rx is this line here. What would I be able to sum to get Rx? Exactly. So as long as I know x1 and x2, boom, I've got Rx. And if I have Rx and Ry, I can use Pythagoras, or if I have an angle and 1, I can use trig to solve for the missing component. y1 plus y2. Now, y1 plus y2 will always be true, but remember, sometimes it could be negative. So if this other vector wasn't going up as well, if it was going downward, we would be adding it as a negative or subtracting it. So it depends whether they actually sum or whether they're actually going in opposite directions. And this is going to be a big part of this whole entire course, is looking at your arrows. Are they going to sum? Are they working together? Or are we going to subtract? Are they going in opposite directions? Okay, so then of course you would solve for your R resultant using the formula we already know.